Friday, we left off right about here, right? I can't remember, some classes we actually worked all the way through this example, some we didn't, I'm not sure, so let's just do it from scratch. Given a function, if we're looking for its inverse, first we need to decide if it has one. Function and its inverse, swap x and y. So the way you check is to use a horizontal line test, because a horizontal line test on a function is going to tell you if when you swap x and y, you would have a thing that's still a function, right? I think, yeah, I drew something like this on Friday, like y equals x squared. If I think of that as my original thing, that does not pass a horizontal line test, because if I swap x and y and turn the whole thing sideways, what I get, the pink graph here, would not pass a vertical line test, right? It's not a function, so it's not, the original thing's not invertible, not one-to-one is what we call that. So for example, this one, y equals 1 minus 2/3 x, I would just graph that. Take a look at the graph and convince myself that that does pass a horizontal line test, right? Anywhere I can imagine a horizontal line passing through that, it's only going to hit the graph once. Okay, once we've checked that, if it fails that, there's no point in going any further. You just stop and say it's not one-to-one, so it doesn't have an inverse. No good. Sorry, one moment. Disconnected the thing. It does have an inverse. The way we find it is to rewrite it with x's in place of y and then solve for y. All right, so if I'm going to take that thing and solve for y, what do we need to do? Do what? Yeah, I mean, we want to move everything away from the y term, right? So y is on the right-hand side of the thing. I want to move everything else to the left. What should I start with? Subtracting 1. All right, so I'm going to subtract 1 from both sides. X minus 1 is negative 2/3 y. Then what? A negative 2/3 you can think of as multiplying by 2 or by negative 2 and dividing by 3 or by negative 3, right? So you can either do that all at once with like 3 halves or dividing by 2/3, or if you want to do it one piece at a time, I could multiply by 3. That would cancel that. 3 times x minus 1 is negative 2y. Divide by negative 2, and we get, oh no, room. Negative 3 halves x minus 1 equals y, something like that. That would be our inverse function. Right, so I might name that, what was this, g? That's g inverse. We could, if we really wanted to, like try to dig into the thing and describe what's happening. This one, the 2/3, you're multiplying by 2, dividing by 3, adding 1. Here you're doing the opposite things, and they're happening in reverse order, right? So again, that's what's going on. But solving for it like this tells us how to do that without having to just sort of like figure it out, right? So if I graph that, negative 3 halves x minus 1. And again, the idea is that a function and its inverse are symmetric to one another across that line. You can kind of see that, right? They cross in one spot and it's on that line, right? So we swap all the x and y values. So if I got further into it and looked at like the y-intercept here, gonna look a lot like the x-intercept for the other one, right? So you get that symmetry across that line. Okay. All right. Y'all tell me about this one then. First thing again should be to do a horizontal line test. Is the function one-to-one? Y equals, find the cube root, 2x minus 1, cube root of 2x minus 1. Okay. There it is. I don't need that on right now. Does that pass a horizontal line test? Can I draw horizontal lines? And can I draw a horizontal line anywhere that hits the graph more than once? No. You can zoom out, you can move it around if you want. Right, the two ends of that thing are going up and down, right? Away from each other. It sort of, goes up, passes through the origin here, levels off the other way a little bit, but they are pointing in opposite directions and it doesn't like double back on itself or anything, right? So anywhere I would put a horizontal line, it's only going to hit that graph one time. Okay, so it's one-to-one. Because it passes a horizontal line test. Check that out. Horizontal line test. So I'm going to go find its inverse then. We have y equals the cube root of 2x minus 1. I'm going to write instead x equals the cube root of 2y minus 1. Because that's how you take an inverse. You swap x and y. So everywhere there's an x, I'm going to write a y. Everywhere there's y, I'm going to write an x. And then solve for y. How do we solve this for y? Yeah, get rid of the biggest thing first. Biggest thing happening on the right-hand side of that is that cube root. The opposite, the inverse action or operation to that would be cubing. So if I cube both sides, that root and that power, cancel, undo each other. We get x cubed is 2y minus 1. Then what? Add 1. We should be, sort of gradually moving things away from the right-hand side. Or away from the y term, right, which happens to be on the right. And then last thing would be divide by 2. Yeah. So y, which is the inverse to the function f, is x cubed plus 1 over 2. And again, we were able to do that without, having to, oh, sorry. There you go. Without having to try to parse through what happens and in what order and reverse those, right? The solving part does the reversing the steps and reversing the order for us. Okay. All right. So were you able over the weekend to get 2.6 stuff done and a good jump on 6.1 stuff? Okay, good. No one's enthusiastically saying yes because I did, look this morning. So, yeah. Okay. Well, you know what's ahead of you. Let me know if you have questions, I guess. Is everybody okay with this idea, like how we find an inverse to a given function? Check first. Don't forget that part. Because if it fails a horizontal line test, it doesn't have an inverse. So going to look for one isn't going to do anything. Like it's not going to take you anywhere meaningful because it doesn't mean anything anyway. Okay. All right. Okay. So the other sort of type of thing. So far, what are we, 3 weeks in? Yeah, it's week 4. So the first 3 weeks, what we've done so far is a lot of like general, here's how functions behave and how they work in general and how we do stuff with them. We haven't really done much in terms of specific functions or why we care about them and that kind of thing, right? We looked at a few like function types, but pretty much just to get shapes of graphs. Pretty much the rest of the semester is going to be looking at specific functions of family, or so the backwards families of functions and what they do and why we care and where we use them and how we work with them. And we're going to start that today with looking at the absolute value in a little more detail. So you know some stuff about taking an absolute value. We've seen the absolute value function. Got the graph of it here again for you. This is a reminder, but what does the absolute value function look like? V-shaped graph opening up, yeah. Straight line segments, sharp corner. And for starters, we're just going to look at a straightforward transformation of an absolute value graph. So I gave you the graph y equals absolute x. I want you to graph y equals absolute x minus 1, all inside the absolute value, then plus 3. Once you have that, which should be hopefully pretty straightforward by now, some questions to answer. On this graph that you come up with, right, this translation of the absolute value function, where is that function equal to 4? Where is it less than 4? Where is it greater than 4? So think about, what that means, how you answer that. Talk about it with your group. Think about, looking at the graph and trying to find that information. All right, so first the graph real quick. There's the absolute value function. What does the absolute x minus 1 plus 3 do to it? 1 to the right and up 3. Okay, so where does this end up? First quadrant vertex, the corner should be at 1, 3. Everybody agree?
Yeah, we're good with that? Okay. All right. So with that in mind, then,
But you get back to answering those questions. Where is it equal to 4? Where is it greater than 4? Where is it less than 4? Okay, so how can we answer that without doing any work at all? Just based on what we have right now. Find 4 on the X or the Y? Sure. We have those things defined, right? Y equals the absolute value X plus 1, whatever, the thing, right? Okay, we have the thing here, right? So if I'm setting that equal to 4, is 4 an X or a Y? A Y, right? If 4 was the X value, we'd be finding like f of 4, right? So setting this equal to 4 means what happens when Y is 4? And that's probably a good way to, interpret this. If I think of the right hand or the whatever, if I think of this side as a function, the question this is asking is, where is Y equal to 4 on that function? Like, where does it pass through that height or that level? So what we want to do is look for 4 on the Y-axis and then figure out where the function is, right? Similar to the problems that we worked through a little bit last week and the week before. This is given a Y value, how do you find the X? The other way you can see that is just look at the equation. What's my answer to this going to be? X, right? I mean, X is the thing that we don't know when we write this equation down. X stands in for a bunch of things, maybe, and we're looking for specifically, okay, what values satisfy this? Well, my answer is going to be X. So it must be that I'm given Y then, because those are the only 2 choices, right? We're only interested in 2 variables. Okay, so if Y is 4. We're right here. What X values go with 4? 0 and 2. Right, just looking at that Y value and then checking to see the X's that go with it. When X equals 0, and again when X equals 2. Okay, solutions to that equation, then there are 2 of them, 0 and 2, right? So sometimes you might see that called like the solution set. We can sort of always talk about a solution set, but we don't normally when it's just one thing, but it would be 0 and 2. Again, I'm not going to do the curly braces thing very often for something like this, but you might see it in like the homework online. you know, either the like braces are already there or they're not, or whatever. I'm fine with you just writing x equals 0 and x equals 2, or even just listing them. X equals 0 and 2, like that's fine, right? So again, stuff that you hand me, any of these 3 versions of this is fine. Might watch out for the stuff online though. Okay. Questions about that? That's solving an equation graphically. It doesn't care what kind of equation it is, right? That could be an absolute value, it could be a parabola, it could be any kind of graph in the whole universe. Some weirdo, bizarre thing I've never seen before, right? This is the graph of y equals f of x. But if I want to solve f of x equals 1, all I would need to do is find the y value 1 and see what happens, right? So we could do that no matter what. Any kind of graph you start with, we can solve an equation graphically by using that same approach, right? As long as I can sort of see where things happen, we're good to go. Right? Just the same way, but you know, kind of going the opposite direction, that if I gave you a graph, even if you don't know what the equation looks like, you could find f of 2, right? You just go to x equals 2 and see what the graph does. So it's the same idea, but you know, sideways, going the other way. Okay, so there's that. Now, what about answering where it's less than 4 and where it's greater than 4? And one more time. Inequality faces the bigger thing, right? Or opens toward the bigger thing. So this says, where is this function less than 4? This says, where is the function greater than 4? Well, how could we find that from the graph? We figured out where they're the same. So how could we figure out where one is bigger than the other one? All right, y'all talk about it for a minute. See what you come up with. Now where they're equal. Now I want to figure out where they're not equal. This way. All right, what do you got? What happens if x is 1? If x is 1, y is 3, right? Okay, and 3 is smaller than 4. Okay, so it works there. Is it just equal x equals 1 though? Where else? I mean, there's 1, right? There's 1. So it definitely works there. What about 1.1? 1.2? 1.5? and 1.999 and 0.99 and okay, so what is it? It's not just a single value, but it's a range of values, right? Everything between where and where? Between what? 0 and 2. Because what happens at 0? It's 4. Okay, so they're equal at 4. Or sorry, at 0. At 0, they're both 4, right? Like both sides of that would be 4, and 4 is not less than 4. Okay, so not at 0, but what about 0.00001? That's okay, right? As long as you're on that side of 0, you're okay? Okay, and then all the way until we get to not quite, but almost 2. Okay, so everything between 0 and 2, well, what do we want to do with the endpoints? Keep them or not? Not, right? So how do we do that? Everything between 0 and 2, not including the endpoints.
Oh,
Yeah, okay, so one of the two, right? Square brackets or parentheses? Parentheses because we want to be open at the ends, right? Close to, but not including, because what happens at 0 is that they're equal. What happens at 2 is that they're equal. So what if this said less than or equal to instead? Then square brackets, right? Because they're equal to it. Okay.
So this is true for all x values between 0 and 2, or in other words, everything in there.
Right? Another way you can think about this question is think about the actual graph of the thing. Think about that like I don't know, like a roller coaster track or something. If you're riding on it, the question is, when are you sitting below? When is the height of the track lower than 4? Okay, well, if I'm riding along the thing, I'm using x values to keep track of where I am. Here, we're higher than 4, higher than 4, higher than 4, sitting above it, right? Because all the y values are 6 and 5 and things that are bigger than 4, right? Once I get to 0, though, we hit 4, and then we sit underneath 4 for a little bit until we get to 2, and then we cross back over, and then we're headed off the other direction forever. So it's just on this little chunk between 0 and 2.
all right, what about flipping that inequality around? When is that thing bigger than 4?
We know where it's equal to 4. We know where it's less than 4. There's only one other possibility, right? When does the function sit up higher than 4? When are all of its y values bigger than 4? Oh, right here, and right here, right here, right here, and everywhere out this way, right? And also here, and here, and here, and everywhere out that way. So everything not between 0 and 2, but outside of 0 and 2. How do we write that down?
That would be all of this stuff.
I think you're on the right track. 4, though, would mean that you don't start till right here, right? Because we're using x values to keep track of where it is, right? So the y value is the thing we're comparing to. Our answer, though, is, again, x's. Negative infinity to 0. Okay, so reading the number line left to right, negative infinity, so as far out that way as you want. Come in until you get to 0. And what kind of square bracket or parentheses is 0? Parentheses because we can get close to it, but at 0, they're equal. I want it to be strictly bigger than. Okay, so negative infinity to 0. I'm going to write that down.
That's that side.
Of that shaded stuff. And then it's not true in here, right? Because in here, the function is less than 4. Okay, so we leave that out. But then we pick up again at, well, not at 2, but just past 2, right? So 2 to infinity, again,
open or parentheses at 2. And we got two things that we want to sort of take together, but there's a hole in the middle of them. So we join them together with a union. That's the stuff that's shaded there in orange. That's where this is bigger than 4.
If you take, what that means is if you take any x value from this interval or from this interval, so like -4 or 5 or 1,000,000, and you plug into this inequality, this would be true, that the stuff on the left would be bigger than 4. That's what we're saying. Notice that if you glue those two things together, the 0, 2 interval kind of fits in right where that union symbol is, right where that gap is. Because the only possibilities are this one's bigger or this one's bigger, or they're the same.
And they're both strict inequalities, so we kind of threw out the same part. Okay, so that's how we can like handle or think about that graphically. Absolute value graph is always like a V-shaped thing like that, you know, is
Sort of sitting. So if we're comparing it to a value, probably we're going to expect something like this to happen, right? Because whatever that height is that we're comparing against, probably it's going to hit the function twice, which means that you're talking about either the things in between where they cross or the stuff outside of where they cross.
okay. So let's think about how we can solve an absolute value like by hand, right? Solving absolute value equations. And as an example, what I give you, the absolute value of x equals 3. So this is asking what x values have absolute value 3. What does absolute value do or measure?
Yeah, how far you are from 0. Right, that's what absolute value does. That's why, you know, probably the thing you remember about absolute value from earlier classes or whatever is that it flips the sign on negative things, right? That's because it's measuring how far from 0 you are.
So if we're thinking about this as like a number line, there's the x-axis, 0 in the middle.
What number or numbers are 3 units away from 0? Exactly 3. 3
and -3. 1, 2, 3. 1, 2, 3. That way or this way. Okay, so the absolute value of x being equal to 3 means that x is either 3 or -3. Right? Because the absolute value of 3 is 3 and the absolute value of -3 is also 3. It's confusing that I wrote those where I did. There we go.
absolute value you can think of as telling you, like, take this many steps away from 0. So what this says is take 3 steps away from 0. Where are you? Well, you're either at 3 or you're at -3. Those are the only possibilities. Does that make sense? Okay. So what if there's more stuff going on?
What if instead we looked at that?
Not a big change, right? I threw x minus 1 inside the absolute value.
Let's wait for the leaf blowers to. It's really fun when they do it on like the morning of the final exam or something. It's like a guy's just standing outside the door revving the engine for 20 minutes. Anyway, not a big change, right? We've got x minus 1 inside the absolute value now. How can we solve this? Say again. Okay, start at negative y, start at negative 1. You mean like as the x value? Okay, so what if x is negative 1? You get absolute value of negative 1 minus 1. That's negative 2. That's 2. Okay, so it looks like we're close at least, right? There might be one solution that kind of jumps out at you if you look at what's going on. Maybe not. That's okay too. What is this? I mean, what is this thing saying? There's a bunch of ways we can break this down at this point. That absolute value of x minus 1, I can think of that as a shift, right? Which way does that go? To the right one. Okay, well, if I know that solutions to this are 3 and negative 3, I can just move those both to the right one. Move those both to the right one, they become 4 and negative 2. You can check those are the solutions, right? That is how you solve this. That gets harder if there's more stuff going on, right? If there's like stretching and shrinking and all that kind of stuff involved. But that still works. Guess and check is probably not a good way to go about it. You know, we can maybe use that as a way to kind of inform things at first. Let's think about it this way. What does absolute value do again? Measures distance from 0. Okay, forget about this for a second. What that says is that the absolute value of something, I don't care what the thing is yet, the absolute value of something is 3. The distance from 0 is 3. If your distance from 0 is 3, where are you? 3 or negative 3. Those are the only possibilities, right? Okay, well, if that's distance from 0, then what this says is that whatever this thing is can either be where or where? One more time, Will. 3 or negative 3. Because again, number line sense, it's 3 this way or 3 that way. Doesn't matter yet what's inside the thing, right? The thing that I squiggled over, right? I'm gonna do this a whole bunch. So what I'm doing is ignoring it's not really scary here, but like ignoring some of the details as long as I can until we figure out what's going on. I started with an absolute value. Absolute value, what's going on is it's distance from 0. Okay, so I'm gonna ignore the details. I'm gonna use the distance from 0 idea. Distance from 0 is 3. Okay, well, that's either 3 or negative 3. Now that I've got it sort of broken up or decomposed like that, now I'm gonna go look at the details. And when I look at the details now, I see like, oh, I've still got a thing to do, right? What do we still have to do here? I'm trying to solve for x. I have x minus 1 on the left, so we need to put the 1 over, right, by adding. So x equals negative 2 or x equals 4. Those are the 2 and only 2 places that the absolute value of x minus 1 is equal to 3. Which again is the same thing you would get if you took that, you know, thought of it as shifting what we did before, but again, there will come a point where that becomes kind of too much to keep up with. This idea though, using what absolute value actually tells us, which is distance from 0, to sort of break things down,
Well, now I've taken it from scary new equation that I don't know how to deal with to much more familiar, simple little linear equations that you've been doing since, 8th grade or something. That are much more like familiar and easier to deal with. Questions about that? Okay, so what if
we wanted to solve that? The absolute value of 2x plus 1 is equal to 7. I'm going to, again, suggest, and I'm pretty much going to do this all semester, at first, because, thinking ahead to like a final exam or something, it's not going to say like, today is absolute value equation day, so let's do the absolute value equation thing. It's just going to be, here's a thing, solve it, right? So look at sort of the shape, look at what's going on first, right? Pause for a second, don't worry about the details so much, think about what's going on. Absolute value. Okay, absolute value, distance. That's the thing that's the like one word you want to tie to that for starters, distance. Distance is 7. Okay, so if I'm on a number line and I get to go exactly 7 steps away from 0 in one direction or the other, where do we end up? Plus 7 or minus 7? Okay. Well, that means that whatever this is could be either what or what? 7 or negative 7. I haven't had to worry yet about what's underneath that orange scribble, right? I've just decomposed the absolute value part, right? So breaking that down, that's the first step. Now I'll go back and look at it and hope that what I have at this point is going to be easier to manage. Well, on one hand, we have this, which is easy enough to manage, right? Just a linear equation, move stuff away, subtract 1, divide by 2. And we have this. Same deal. Linear equation, easy enough, subtract 1, divide by 2. You're good to go. We're just solving 2 of them at once, right? To get the 2 solutions here. So 2x is negative 8, x is negative 4, 2x is 6, so x is 3. Maybe even put a little, sort of dividing line in here if you want to show that, we are doing like sort of 2 separate calculations there. You okay with that? Do you have any questions? All right, well, what if instead we wanted to take the same thing or almost the same thing and figure out where it's greater than or equal to 7? What could we do? We can maybe go to the graph, but then you run into a couple of things that, maybe you can't see it. If I was comparing this to like 10,000 instead of 7 or something, then that gets weird because I got to zoom, but then like it gets hard to see. If they don't land on nice coordinates, if it doesn't land at like 3 or something, then that gets a little bit funky too. Well, we know how to solve the equation, right? And we saw with the one at the beginning that the equation is related to the inequality at least. This one's even greater than or equal to. So we're going to be using like square brackets, right? Including endpoints. What do we know already? about this or something very close to this. What did we just do? We know that this is equal to 7 when x is -4 or 3. Right? We just did that. We just solved the equality, the equation. To solve the inequality, think about the x-axis. We're trying to figure out when this is true. We just figured out that when we get to x equals -4 or x equals 3, that those two things are equal at those points, right? They're equal there. To figure out where the thing on the left is bigger than the thing on the right. Well, we've already seen what the graph looks like, right? V-shaped graph, it opens up. They only cross at these 2 points. One way to do this would be to figure out what happens out here and what happens in between and what happens out there. So I could take x values from in between these things. Something smaller than -4, like -5. And something between -4 and 3, like 0. And something bigger than 3, like 4. If I take values like that and test them in this inequality that we're trying to solve, so for example, if x equals 0, this becomes 2 times 0. And 2 times 0 is 0. And 0 plus 1 is 1. And that's 1. So is 1 bigger than or equal to 7? No. That means I don't want any of the stuff between those two values, between -4 and 3. Because that inequality is not going to be true for those things, right? It's not true for 0, so it's not going to be true for anything else in there either. Do the same thing with 4. Plug 4 in, you get 2 times 4 is 8, plus 1 is 9. Is 9 bigger than 7? Yeah. So it's true out here. Same thing would happen out here. So our solution set becomes all of this stuff up to and including -4, and then all of this stuff bigger than 3. There are some more details that you need to kind of work through there. I left out testing those other 2 points. You should work through that, like test these, but do it the same way I just did with 0. Test those, see if it's true or not. Bottom of the page, there are 4 example problems. Take a look at, at least work through like the first 2. Tomorrow we'll spend, 10, 15 minutes, something like that, working through that and any questions that we need to. Okay? Have a good day. I'll see you tomorrow.